gpio.s I already did previously in lesson 5 and lesson 4, but the code is similar. It's the same code for systemTimer.s and gpio.s, so I'm not going to spend time on those. I'm going to spend talking about frame buffer.s, mailbox.s, and main.s. Okay, so in frame buffer.s, we're communicating with the graphics card using the frame buffers, and the message is consistent to point structure below. So I'm gonna show you the output on the TV of the monitor later after I explain the code. So over here it states that we're using universal 32 width and universal 32 height, and width and height with the pitch. So these are the frame buffers information, and as you see, we're starting with 1024 by 768, 1024 by 768, and 16-bit color, I think. So this is the width of the resolution, 1024 by 768, the height, and we're using a 16-bit depth color, and basically the width uses register 0, the height uses register 1, the bit depth uses register 2, compares the width, which is 4096, the I think the bit or the byte, and then compares the height with 4096 too, with the bit of the byte, and then it uses the comparison with the bit depth 32 pin, not 32 pin, but the pointer, GPU pointer for 32. Then it uses also and the result is register 0. So we move high, result is equal, uses pin 0, and then move high, we return the address to the program counter, and then we push the register 4 in the return address. So it's gonna give us the info address of register 4, and we load the info address, which equals frame buffer information. So basically the width uses register 4, and it's gonna use 1024 because it uses 0 as a pin number. The height is register 4, but it uses pin number 4. So we're gonna go to pin number 4, which is height, 768 resolution. The height register number 4 uses number 4. So if we go over here, number 4 is the height, 768. Then the width resolution uses 4, number 8. So we're going over here, number 8 is 1024 lines. The height is register number 4, so it's gonna use number 12 pin, which is D height 768. The bit depth is register number 4, but it uses pin number 20, so it's gonna use 16-bit color. on that. And then we move register 0 to info address, which is that, and we add the register 0 with that number. Address is 04 and 0000. And then we move register 1 equal is the pin number 1. So basically the mailbox we wrote, right, move register 0 to pin 1, mailbox red, and then this equal with the number 0, pin 0, which is the width, and then if it's equals to pin 0, then we move on to the result with number 0, and then we pop the NE, which is register 4 in program counter. Register 4, that's gonna be register 4. It's the height and the width. Register 4, the height and the width, and again the width and the height, and also the 16-bit depth color. So, and then we move result the FB info bar address. We pop the R4 that copies to PC counter, and then we just get the result at the FB info address of this. So basically we get the output already for the screen for the frame buffer. Next thing I'm going to talk about is the mailbox.s file. Okay, we start with global get mailbox base. We load the function register 0 in this address. We move the program counter. We move the return address to the program counter, into the program counter, and then the global mailbox we write, it's going to be register 0. I think this is the color. I think it's going to be, let me see what color that will it. I think it's black. I'm not sure. Let me check. So if I Google it, it's the RGB conversion color code information, I believe. Yeah, basically it's the color code information. And then we move any return address into the PC, program counter. We compare the register 1 with pin 15, and then we move high the return address into program counter, and which it copies the program counter. And channel 1, then the channel R1, and then value is R2, and then move the value to register 0. So, and then we push the return address, and then we get the mailbox base. The mailbox is register 0, which is the value of that, and then we wait, and then the status comes up with register 3. We load the status mailbox with 018, 0x18, and then we test the status if it's 0x8000. Wait, this address status, I mean. And then we BNE waits, and then we add the value to the channel, the value mailbox, and then we pop the PC, program counter at the end. Basically, mailbox is being read and compares with the register 0, which is number 15 pin. basically, and that's it. And this is the address for the unread mail and the pop program counter. That main file has changed in this experiment from lesson number 5 because they changed it because it's going to be doing something different. It's going to use the color to display it and the resolution of the color on the TV. So we start with system directives as always. Then we appoint the stack pointer. We move stack pointer with this bit. Then we set up the screen, which is it's gonna move to register 0, which is 1024 lines, by move register 1, which is 768, and then move to register 2 with number. It's gonna be 16-bit color. So we're gonna initialize the frame buffer. It's gonna check for a failed frame buffer. So we test if it's equal. Register 0 if it equals to pin 0. No error. Then we move on to register 0 16-bit. 16-bit color, and then move to register 0, which is 0, which that's going to be in the resolution, the width of it. So, and then we get the gpio function, move register 0 to 16-bit color, using register 1 as pin 0. Get GPIO. Error. No error. If there's no error, then FB information address will be register 4, and then move the address to register 0. So we set the pixels forevermore, and then we render them using register 3. Load the FB address, FB information to number 32, which is, check what 32 is, the GPU pointer. So we'll use register 0 to keep track of the current color. The current color is going to use R0, register 0, the Y register 1, and then we'll move Y to resolution 768. We'll draw a row of coordinates demo showing the screen on TV, what it does for this lesson 6 Raspberry Pi.